Hello. Thank you, Lindsay. Thank you, Access Lift and Handlers. Thank you for the opportunity to be here. So I'm going to talk a bit about batteries and electrification in the access industry. It's a topic near and dear to my heart. Pretty exciting times for us in product design in that realm. All right, I'm going to figure this out. There we go. So I want to zoom back out a minute, and before I talk about batteries specifically, I want to talk about electrification in general. So when you're thinking about electrifying a product, we've been doing that at Genie for a long time. Electrification is nothing new to the access industry. We've been doing it for 35 years. 70% plus of our products are electrified today or hybrid, so it's certainly nothing new to the industry. But I want to talk a little bit about the considerations for product design around electrification. So the first one's obvious, it's performance, right? So how do you want the product to perform? Some of the important things are trainability. So that doesn't get talked about a lot around electrification, but it's actually a big issue. So the traditional way you drive a mobile elevated work platform is with a mechanical drivetrain or hydraulics. But as you start getting into electrification, you start talking about things like direct drive with electric motors, that kind of thing. So that's definitely an aspect of electrification that's really important to our products. Next one, of course, is duty cycle. That's an old one. The herd test, the origins of the herd test and where that came from, if you guys are familiar with that. But it's a loose, it's not an official measurement, but it's a loose measurement that people use to talk about the duty cycle of an aerial work platform. That can be a very complicated topic because what is the typical duty cycle of an aerial work platform? You think about the car industry, it's a little more straightforward, right? You have a lot of data about, okay, I need to drive 20 miles to work. That's about how much electricity I need, that kind of thing. With aerial work platform, it gets a lot more complicated because the products can go into a wide range of applications. They may be driven all day long. They may be driven every couple hours. So it gets a lot harder to predict and define what kind of duty cycle do you need, and how long do you want the unit to work, how often is it going to be charged, those kinds of things. And again, something that doesn't get talked about nearly enough is temperature. So electrical systems, I think everybody knows, if you leave your cell phone out in cold weather, suddenly that battery just goes right down. So same thing in aerial lifts, right? So if it's in cold weather, your batteries do not work as long unless you do something like put a heater in there or something like that. So it's definitely a consideration. What kind of temperature range do you want an electrical machine to work, and for how long? That's a big consideration. Next one, obviously, is cost, right? So when you're thinking about a system, it's the cost of the system, so that gets passed on to the customer who's buying the product. If you can put in a very nice, elegant system, but if it costs a lot of money, maybe people aren't going to be interested in it. And then there's obviously the resale. So how long do your batteries last? When do they wear out? That kind of thing. So that becomes a big factor in terms of total cost of ownership. And then finally, of course, maintenance. The appeal of a lot of electrical systems, theoretically, is there's less maintenance, but you really got to prove that out. And finally, there's other things to consider. The first one's safety. So particularly you get into batteries with high voltages. So there's really two kinds of safety when you think about electrical products. One is in use. So things like if you get in a collision or a unit falls off a truck, what happens with your batteries, those kinds of impact situations. Or vibration. Vibration is actually probably one of the hardest things my team deals with in designing products, and it's the vibration people don't think about. It's actually the vibration in transportation. When units are riding around on trucks on the highway, they experience incredible amounts of abuse, more than you could possibly imagine. Things fail at really high rates, and it's that long-term vibration that's a big issue. So that gets to be an issue with electrical systems, but it's also in use. So things like maintenance. When you get to higher, and I'll talk a bit more about this, higher voltages on these machines, maintenance starts to become a big deal, and I'll talk more about that. Charging. So both the charging system you're going to put on the machine, but also in terms of the application the machine's going to be used in. What's the charging availability? For instance, in China, construction sites get hooked up to the grid pretty early in the project, so electricity is widely available. But in a lot of Western countries, it's typical to hook the job site up to the grid at the very end of the project. So when you're at the beginning of the project, you're not on the grid, you're running off maybe a trailer, a generator on a trailer or whatever. The availability of power to charge your equipment becomes a big issue. And finally, regulations. So there's, and I'll talk more about regulations, but you need to think about that. What regulations does the design need to comply to, as well as in use? What types of regulations are there? So that's just kind of overview. I just want to level set that, you know, it's about, when you're thinking about electrification, it's more than just batteries. So I want to talk a bit more about that with the next slide. So I'll get into the kind of the guts of the thing from a design standpoint here. So when you say you want to electrify a product, it's obviously way more than just what batteries do I want to use. There's a lot of considerations. The first one is controls. So traditional machine, right, that runs off an engine, it's 12 volts. Typically, your whole control system runs off 12 volts. You're just playing around with 12 volts. It's pretty easy. It's a well-defined technology from the automotive industry. Components are widely available, that kind of thing for 12 volts. Well, as soon as you start electrifying, the voltages start coming up, it gets a lot more complicated. So you're switching heavy power. That's a whole technology in of itself. There's safety concerns, there's efficiency concerns, performance concerns. So control systems get a lot more complicated when you start electrifying machines. Drive systems, I talked a bit about that, but again, that starts getting much more complicated from a technology standpoint when you're driving things with electric motors. Charging. So again, charging for a long time was pretty simple. You get a low voltage charger, they're widely available, technology is well understood, the charge profiles are typically pretty simple, is pretty simple technology, but as we're getting into more elaborate and sophisticated electrical systems, charging becomes a lot more complicated. Battery management, BMS. If you haven't heard the term BMS, you're going to start hearing about BMS because the batteries are becoming much more sophisticated, and I'll talk a little bit more about the batteries specifically. But the whole idea that you basically need a control system monitoring your batteries, maintaining the health of your batteries, and this also gets into the whole world of telematics, because typically you want to be connected and be able to see what's going on with the batteries remotely with your equipment. So that becomes a much more complicated endeavor. And then just rethinking hydraulics in general. When you're talking about an internal combustion power source, typically you have tons of power. So power is not the problem. So you can be pretty, I don't want to use the word sloppy, but I guess it's sloppy, inefficient with how you use your hydraulics because it doesn't really matter. You literally got power to burn. So your hydraulic systems, whether it's the drive system or the lift system, you don't think a whole lot about the efficiency of those systems. But when you get into electric drive machines, the efficiency of your hydraulics starts to become a much bigger part of the equation and something you really need to think about. And finally, the batteries themselves. So I'm getting there. The batteries is the heart of this presentation. Pretty important. So I'll transition now to batteries. So when you get into the battery world and what's going on with the battery world, it's kind of crazy right now. So for many years when I started designing lifts at Genie a long time ago. It was pretty simple. it was all lead acid, right? Very well understood, stable technology, pretty straightforward, lots of suppliers, lots of components that work with it. Wasn't too hard. So lead acid's awesome. It's plentiful. It's relatively inexpensive. The problem with it is the energy density is poor. It requires a lot of maintenance. And of course, lead acid batteries wear out relatively quickly. So, you know, it's nice in the sense that it's easy to work with, but it's not ideal. And so, you know, later on, AGM batteries came in. AGM batteries are, you know, essentially lead acid batteries, but they're fully sealed, so they have less maintenance, they're more expensive, but still suffer from a lot of the same problems that lead acid does. So, of course, lately, more and more talk about lithium in our industry. Of course, lithium's been around for a while. It's in cell phones, et cetera, et cetera. But, you know, thanks to Tesla and some other companies, lithium is really starting to become more of a mainstream product in mobile equipment. The world of lithium in batteries is truly the Wild West right now. There's no standards. There's no, oh, I'm just going to go get a lithium battery for my product. When it comes to chemistries, so there's many different kinds of chemistries, and new ones keep coming out every day. Even the physical form factor of it. There's cylindrical cells, there's prismatic cells, there's pouch cells. Everybody's out there talking about which is the best architecture, which is the best chemistry. It's wild. As a designer, there's many options to choose from in batteries, and it's changing literally every week. Somebody's talking about a new technology in batteries. So that's the important things to understand. When someone says, hey, I got lithium batteries, that really doesn't tell you much. That just says they have a lithium type chemistry in their battery, but it really doesn't tell you anything about the performance level, how tested is it, the cost. It really doesn't tell you anything because it's just wide open. And that really brings me to my second point, regulations. That's the Wild West right now. So there are a few regulations people are out to. There's a couple UL standards. There's 2580 and there's 2271, which a lot of manufacturers are gravitating to in terms of the standard you design and test your battery to. There's also an IEC standard, 62619. But there are no standards for our industry, certainly, around electrification or batteries, which is a big contrast to IC engines. The hoops my teams have to go through to qualify an engine are incredible. There's government regulations in just about every country now, but there's also regulations from the engine manufacturers. So to qualify a new engine and a product, this is an incredibly rigorous process. Opposite is true for batteries today. There's nothing. There's no requirement. There's no government requirement. There's nothing. It's wide open. So you can really see everybody doing different things, and it's pretty confusing, actually, to figure out. So again, when someone says, oh, I've got lithium in my machine, that could mean anything. It really could. So just something to be very aware of as you're thinking about lithium for your products. You should be asking some questions. And that brings me to my third point, testing. So again, these standards call out very different testing regimes. What kind of testing are they doing in their batteries? Because for a lot of these battery systems, they're so new, there's actually no history to look at in terms of how long do they really last? How many cycles can you get out of them? Because the systems are literally, people are inventing them as we go here. So again, something to be very aware of. Some of these standards do call out testing regimes that you have to follow for your battery. And that's both, there's two types of testing, right? There's just the duty cycle testing, right? How many cycles can I get out of this battery before it wears out? Or how long will it maintain its efficiency? But the other part is the safety aspect, right? We all heard the stories a few years ago about lithium batteries catching on fire in toys, that kind of thing. So, you know, what type of chemistry in there and what type of they tested? What type of testing have they done? Because the last thing anybody wants is to have a machine catch on fire or anything like that. So it's really the testing and the standards behind the testing are critical to the safe operation of this equipment. And, you know, I should throw out, I'm going to do a little self-promotion here. So we've just, Terex and Genie, we've just made a big investment in a company called Aculon, and we did it specifically for this expertise around testing and understanding the standards around batteries, because it's just going to become a really big deal in terms of qualifying batteries and ensuring that the right product for the customer, and there's something that Genie's willing to stand behind. We want to know it's the right product. Costs. Costs is a fun one with batteries. It's all over the place. Depending on the chemistry you choose, the architecture you choose, the supplier you choose, it's really amazing, the costing. So, and obviously the environment we're in right now, with the inflation we've experienced, with the global supply chain issues we're experiencing, it's amazing what's going on with battery costs. So, you know, are they coming down? In general, the cost of the technology is coming down, but right now, what you pay for a lithium battery can vary greatly. So I guess that's just something, it's a bit of an adventure as a designer trying to hit a cost target on a product, and the technology is so wild in terms of how it's costed right now. And then, of course, availability. As a manufacturer, the last few years have been really interesting, trying to keep our manufacturing lines going. And certainly as you're designing in a new technology, new types of batteries, that kind of thing, it gets even more interesting. And, you know, there's a lot of articles right now. Google that. There's tons of articles about lithium availability. It's really going to become a global problem to solve, right? So the numbers getting thrown around, the automobile industry is investing $80 billion in developing battery technology right now. There's going to be this massive demand globally for new battery technologies, and where all those batteries are going to come from is going to get really interesting. So the availability we're going to have going forward is really hard to predict, and what compounds that, makes it even harder, is that technology keeps changing. It's not like it's one stable technology and okay, we all need to figure out how much of that I can get and where I can get it. It's like, well, what I'm trying to get today may not be what I want to be getting 5 years from now. So it's moving around. It's pretty interesting. And then end of life, right? So there's going to be this gargantuan expansion of the batteries used in everything, automobiles, construction equipment, everything. Well, what happens with all these batteries? And there's a lot of questions about that right now. So Scott mentioned it, but in the Inflation Recovery Act, there's a lot of money to develop battery sourcing in the U.S., right? So it's really incentivizing the localization of battery production. Today, when you look at the raw cell level, like the basic building blocks of a battery, 94% of the global production comes out of Asia. So the idea is, in the Inflation Recovery Act, is, hey, let's incentivize that in the U.S. So that's interesting, but it will take a few years for domestic production of batteries to ramp up. So in the meantime, recycling is going to start to become a pretty big deal. And there's a lot of companies making very big plays in the lithium battery recycling industry right now in the US, because the idea is there's not going to be enough supply for new batteries. So if you can crack the code on how to recycle a battery efficiently and come in at a similar cost point to a new battery, that could be a really good business. So there's tons of money, billions of dollars going in right now into battery recycling technology. So again, that's all evolving, because It's not here yet. We don't have gigantic quantities of batteries in old cars that need to be recycled yet. That problem is coming, right? So everybody's trying to look ahead and say, okay, I've got all these cars with an old battery in it. How do I get the value out of that? So, you know, I think hopefully I'm painting a picture here. I can't sit here and talk to you about, okay, this is how batteries look, this is what size they are, this is how long they last, you know, these are the different flavors, because it's changing quickly. I guess that's my whole point here. It's pretty exciting, but also pretty hard to figure out if you're a manufacturer trying to figure out what battery system to put in your product, or you're equipment owner. I want to buy equipment. Which lithium package do I want in my product? Do I want to have lithium in my product? It's a bit tricky right now because it's changing. Right. So the future of batteries and aerials, it's a little fuzzy, as I hope you're getting the picture here, because things are changing and evolving quickly. Certainly, electrification is going to become more and more common in really bigger and bigger machines. That's what we're seeing. So for the last 30 years, nobody really offered anything much above 45 feet in that range, because that's about as high as you can go. We have a 60-foot. We now offer a 60-foot boom that's electrified using flooded lead acid batteries. That's about as high as you can go with a flooded lead acid battery that gives you enough power density to operate the machine. Above that, you either need a lot of batteries or you need to start using lithium. And that's, you know, you need that higher power density on those bigger machines. And certainly if you get into equipment like electrifying a telehandler, for example, you need a lot more power. So it's really the practicality of doing that with flooded lead acid really drops off, and you need to move to a different technology. So really the big question in this first line there is the right technology at the right time. It's the right technology for the manufacturers, it's the right technology for the customers, and that's a hard thing to peg right now because it is changing so fast. The technology is changing, the costs are changing, the reliability is changing, it's all changing. So I wish I had a simple, quick answer for you, but it's a moving target. So things to consider today, of course, the cost of the product. I would look at that. That's something obviously equipment purchasers do every day, but definitely figuring that into the equation around electrification. Regulations and ESG, that's moving too, right? There's a lot of regulations in development now in terms of both all the standards committees are starting to talk about it in terms of product design, but also in use, right, in various municipalities. And I should point out, it goes beyond just emission standards. That's the big one, right? Everyone's saying, oh, well, you know, we're going to outlaw diesel because of emissions. The other very interesting one is there's a lot of regulations now cropping up around sound and noise emissions. So particularly, there's a number of cities in Europe, basically, at night, are highly constraining the amount of noise you can emit from a piece of equipment. And so it's really that's driving electrification, right? Because if you're going to fire up a diesel engine at 1 a.m., that's a no-go in a lot of neighborhoods now. So it's, okay, I got to get electric just to get under that noise requirement. So it's not just emissions, it's noise as well. Charging. So I haven't talked a lot about charging. Charging is the big challenge for construction equipment, right? Because, I keep moving away from the microphone, I apologize. Charging is the big challenge, right? And it's the same in the automobile industry, right? That's the big challenge because it's, you know, all these electric cars are coming out, but if you don't have a driveway and enough money to install a charger in your driveway, do I really want to invest in an electric car? And it's a similar equation for the construction industry. It's great, love that electric machine. Where the heck am I going to charge it? Particularly, you get to the bigger machines, you're not going to be able to charge it just off a 220 line, much less a 110. So where are you going to charge it, and how are you going to do that is going to become a bigger and bigger question. And I guess I want to put a little line in there, I want to put in a plug for hybrids. Again, similar to the car industry. A lot of the car manufacturers, particularly Toyota is stuck to their guns on hybrid. And it's because they firmly believe it's going to be a long time before everybody is able to buy an electric car. And that hybrid offers a good compromise. In our products, all the way up to 60 feet, a lot of them we offer in electric or hybrid. And hybrid is definitely the more popular option right now. And it's the whole charging question, right? If you can't charge it, if I can't plug into 440 somewhere or 220, I need another option. And having the ability to charge it on board with the motor is much more preferable. The other nice part about hybrids is the engine size is much smaller, and so you don't have to meet the stringent horsepower requirements around engine certification. So it's a really nice compromise right now. Hybrid technology is, I think, going to be here for a while. And particularly if you think about applications for our products that aren't around a metro area. If you're way out on a mining site or an oil rig or anywhere remote, you know, to think that, okay, I'm going to be able to supply a lot of electric power to that job site, that's a pretty difficult proposition. So I think hybrids are going to be with us for a while and a pretty important part of the equation as we go through this transition. Technical training. We all know it's a really difficult part of the industry right now, finding trained technicians, people to work on the equipment. It gets harder with electrification, particularly as you get to the higher voltages. In a lot of countries, 60 volts is kind of that magic number. If you're below 60 volts, a regular technician can work on equipment. But a lot of countries now, if you get above 60 volts, technicians are required to have special certifications to work on the equipment. And you can understand that from a safety standpoint. You just don't want anybody to just throw open the hood and start poking around in there when you're above 60 volts. So that's another consideration we're going to have to think about. And then in terms of future-proofing your fleet, you know, it's the general thing. You know, thinking about regulations and sustainability, where's that going? Again, it's a moving target, but you obviously need to consider it. And then the big one I keep harping on is that testing, that durability. I can announce now, I've been given permission. Next month, we're actually going to introduce a new option for Genie slab scissors. We're going to introduce a lithium option for that product. And we've gone through more than 2 years of testing to ensure that product will work on our product, on Genie scissors flawlessly. So it's in terms of environmental protection, temperature, vibration, the whole gamut. And that's been very important to us at Genie, is to ensure that we're not just putting something out quickly, we're putting something out we know we're proud to put the Genie name on. So I feel like I went through that really fast, but I've actually used up all my time.
Thank you, Mike. We have time for some questions if anyone in the audience has something. Okay, let's just wait for the microphone real quick. It's coming up behind you.
Thank you. Thank you, Mike. You mentioned about lead acid and AGM batteries, and you said AGMs have some downside to them also. I'm curious, I thought AGMs have a much better capability to come back to full charge than lead acid, so what would be the downside with AGMs?
Well, that's a great question. So they definitely perform better than a traditional flooded lead acid battery, but they still don't have the life of, say, a lithium battery. I mean, it's really just relative comparison. They just still don't have the performance. They still wear out. I mean, it's the same basic technology in both of them, and the chemistry wears out over time. So that's the basic issue. Good question.
Anyone else? Okay, 1 second. We've got a mic coming toward you.
Hey, Mike. You talked about the charging of the batteries, but what does this disposal piece of the batteries look like for the manufacturer to accept responsibility, or the rental customers when they have the machines in their fleet?
So that's a good question. Today, I mean, I think the paradigm is similar to flooded lead acid. In other words, the manufacturer is not part of the equation in terms of the disposal of the batteries. I think that's part of what's driving that is the end of life for batteries is a bit opaque right now. It's pretty hard to know what that looks like. So today, I don't think any manufacturers are, committing to anything around the batteries, and I think that's mostly because we don't know what it looks like. Nobody knows what it looks like. So that's kind of where we are. I mean, I think it's similar to the car industry or anything else, with the exception of maybe Tesla, who is making some claims, but I don't think any guarantees, I think. That's my understanding. I don't have a Tesla, but that's what I've heard.
Got one more?
Mike, from a user's perspective on safety for these products, so, flammability, fires are one item that's out there. You think about now rental fleets transporting these. I know I get some questions about people saying, wow, when we think about, going to the airport and saying, oh, you can't put these in compartments, and now we have these are going to be on this type of equipment going over the road, potential accidents, and what are kind of the guidelines or additional, I'm going to say, hazards that the industry needs to be aware of users specifically?
So that's a great question. I mean, part of it is the chemistry you use. So I'm not going to go down the chemistry road here, but there's definitely chemistries that are far more stable than others. So, I think selecting a chemistry that's stable and safe, that's a really important part of the equation. A lot of it has to do with the battery management system and how sophisticated that is. A lot of it has to do with the architecture of the battery itself. In other words, the lithium batteries are actually made up of a whole bunch of little batteries. I don't know if people know that. If you open up the battery in a Tesla, it's full of thousands of little teeny batteries, actually. And so part of it's around the architecture of the housing for those batteries, so that if one cell decides to overheat, you don't get a chain reaction. So again, it comes back to what standards are you meeting in terms of the design and manufacture of the battery, and also what testing did you go through, because it's really a question of power density, right? So as we start putting more and more power into smaller and smaller packages, if you don't manage that correctly, you definitely can have a problem. That said, it's becoming a much more mature technology, and it's definitely possible to have a perfectly safe battery, but it all comes back to the design and the standards and the testing you go through to get there.
Anyone else? Well, if you do, you can speak with Mike during the coffee break we're going to have here now.
Thank you.